Sum and difference trig identities. Before we get into those though, actually, I have a question for you. Is this true or false? Sine of 60 plus 30 equals the sine of 60 plus the sine of 30. Is this true or false? Well, what we're really asking then is the sine of 90 equal to the sine of 60 plus the sine of 30? Well, the sine of 90 is 1. And does that, then the sine of 60 is root 3 over 2, and the sine of 30 is 1/2. So, does root 3 over 2 plus 1/2 equal 1? And I think you'll agree with me that it doesn't. So that makes this statement false. Okay, so we can't simply, we have the sum of two angles, we can't simply just take the sine of one and add it to the sine of the other. That doesn't work. Okay, instead, it turns out to be this. It turns out to be this. Okay, now there's a way to prove that, but never mind about that. We're just going to take this down. The sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Okay, and that's the sine of two angles that are added together. The difference formula for the sine is this. The sine of alpha minus beta equals the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. Okay, now I don't expect you to memorize these, but write these down and we're going to use this as a reference. So when you need it, you can go to your reference page and get this, the identity for the sine function. For the cosine function, the cosine of two angles that are added together is the cosine of alpha times the cosine of beta minus, note, minus the sine of alpha times the sine of beta. And then the difference formula will be the same except it's plus instead of minus. Okay, again, write these down as a reference. Now, it can be shown for the tangent, the sum formula for tangent is this, and the difference formula for the tangent, or difference identity, is this. Okay, so copy these down, and then we're going to use these as use this as a reference to do other problems. Example 1. We want to find the exact value for the cosine of 15 without using a calculator. Okay, now the cosines that we know are for 0 degrees, 30, 45, 60, and 90. Okay, and other corresponding ones in the other quadrants. Those we should know. But now we can figure out what the cosine of 15 is using those by using a sum or difference identity. For example, 15 is the difference between 45 and 30. So we're going to use the difference formula for the cosine, difference identity, excuse me, the difference identity for the cosine to determine the cosine of 15. Okay, so using this difference identity, we can write this as this, cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. All right, now we know what all these things are. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So we can substitute these in. And then if we simplify this, it simplifies to root 6 plus root 2 all over 4. And that would be the exact value for the cosine of 15. All right, example 2. Let's find the exact value of the sine of 105 without a calculator. Okay, so once again, I'm going to try to use the sines of 0, 30, 45, 60, and 90, and their corresponding ones in the other quadrants to determine this. And I noticed that sine of 105 is 60 plus 45. So to get the sine of 105, I'm going to take the sine of 60 plus 45, and I'm going to use the sum identity for the sine function, which is this. All right, now so 60 is alpha and 45 is beta. And then plugging those into the identity, I get this. Okay, sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. The sine of 45 is root 2 over 2. Okay, and then simplifying, we get this. Now, notice that this is the same as our answer for example 1. So the sine of 105 is equal to the cosine of 15, okay? And there's going to be an identity that comes out of that, okay? But we'll get to that later. All right, now, the sine of 105 can actually be determined a different way. There's an alternate solution to this. I noticed that 105 is also the difference between 135 and 30. So, will we get the same answer if we use 135 and 30 and in the difference identity for the sine? Now 135 is alpha, 30 is beta. All right. Theoretically, we should get the same answer. Let's see if we do. So plugging in the values into the identity. All right. Now the sine of 135 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 135 is negative root 2 over 2. Sine of 30 is 1/2. Okay. Notice the first term, root 6 over 4, minus a negative turns into a plus, root 2 over 4, and yes, indeed, we get the same result. Okay, as you would expect that we need to, right? So, moral of the story is there's oftentimes more than one way to get this answer by either using a sum identity or a difference identity. Okay. All right, we want to find the exact value of tangent of 11 pi over 12. Now, the sines and cosines of what we know are 0, pi over 6, pi over 4, pi over 3, okay, and pi over 2 in the first quadrant, and the corresponding ones in the other quadrants. So we're going to look for ways to get those out of this, okay? And after thinking about it for a little while, 11 is the sum of 3 and 8. Okay, so I can get this 11 pi over 12 by taking one angle as 3 pi over 12 and the other angle is 8 pi over 12, or simplified pi over 4 and 2 pi over 3. Okay, so we're going to use these. That's going to be the alpha and that's going to be the beta, and we're going to use the sum identity for the tangent. Okay. Plugging pi over 4 in for alpha, 2 pi over 3 for beta. All right. And I know what the sines and cosines are, but I'm going to go off in the margin and kind of determine that. So the tangent of pi over 4 is the sine of pi over 4 or the cosine of pi over 4. The sine of pi over 4 is root 2 over 2. The cosine is root 2 over 2. And so that's just equal to 1. The tangent of 2 pi over 3, 2 pi over 3 is actually in the second quadrant. It's the sine over the cosine. The sine of 2 pi over 3 is root 3 over 2. The cosine of 2 pi over 3 is negative 1/2. And that simplifies to negative 1/3, negative root 3. All right, so the tangent of pi over 4 is 1. The tangent of 2 pi over 3 is negative root 3, which I'm going to substitute into this identity to get this. Okay, 1 plus a negative root 3, 1 minus 1 times negative root 3, which simplifies to this. Okay, which would be our answer, except we see a radical in the denominator, and we don't want to have a radical in the denominator, so we have to do a little more work. So now to get the radical out of the denominator, I multiply by the conjugate. So I multiply top and bottom by 1 minus root 3. And then to multiply, this is actually a binomial. And if you did FOIL in this binomial, what it would turn out to be is this. Okay, 1 minus twice root 3 plus 3. Okay, and in the denominator, we have a plus b, a minus b, which turns out to be a squared minus b squared. A1 squared is 1. Root 3 squared is 3. So I get this, which simplifies to this, combining the 3 and the 1. 1 minus 3 is negative 2. And then these are common factors. So I'm going to cancel out the negative 2 from top and bottom. And I get negative 2 plus root 3 as an answer. Okay, next example. write the expression, this expression, as a sine, cosine, or tangent of an angle, one angle. So if you get your reference sheet for identities and find the identity that has cosine, cosine, plus sine, sine. All right, and the one you will find is the one that has a difference, the difference identity for the cosine. All right, so alpha would be 52, cosine, alpha would be 52, beta would be 23. So then the cosine of 52 minus 23, writing that as a single cosine, 52 minus 3 is 29. All right, so it's kind of going backwards from what we did a little bit earlier. All right. Okay. Next type of thing we can do. All right, and this brings back skills that we learned in an earlier unit. All right, so we want to find the sine of x plus y when we're given this information about the angle x and we're given this information about the angle y. Okay, so referring to previous skills, what I need to do is to locate this angle. All right, because I'm going to eventually need the sine, the sines. Okay. And so if we are in the, what quadrant is this? Yeah, right, the second quadrant, okay, where the cosines are negative, and cosine is equal to adjacent over hypotenuse, right? Remember, hypotenuse is always positive, so that negative is going to be referring to the adjacent side, okay? And so I'm going to get something like this, where my values are this. There's my angle, adjacent over hypotenuse, okay? And then I have this side over here, B, that I need to find. And I can find that by Pythagoras, as you recall. So Pythagorean theorem, this gets me here, and then B turns out to be a value of 8, which is positive because it's positive in the second quadrant. Notice we're going up from the axis, so that's positive 8. All right. Then I got to do the same thing for the angle Y. 3/2 pi, y is between 3/2 pi and 2 pi. That puts it in the fourth quadrant. So my reference triangle, you know, where the cosines are positive and the hypotenuse is positive. So that's going to get me here, where the adjacent side is 3, the hypotenuse is 5, and the opposite side, I want to call it A. All right. And then by Pythagoras. All right, and you should recognize that probably by now as a 3, 4, 5 triangle, so that's going to give me A is equal to 4, but it's actually negative 4 because it's in the fourth quadrant. So I'm going to tack on negative sign, so A is negative 4. Okay. All right, so we have our values in here. Okay, and now the sum identity for the sine looks like this. Okay, the sine of x will be opposite over hypotenuse. All right, and the cosine of y we already know, 3 over 5. The cosine of x we already know, negative 15 over 17. And the sine of y, opposite over hypotenuse, and that leads me to these values. Okay, and then multiplying, so 8 times 3 is 24, 17 times 5 is 85. And then that's the first term. And the second term, negative 15 times negative 4 equals positive 60, okay, over 85. And then adding those to get our answer of 84 over 85. So that's the type of problem we can do here. And it gathers on skills we learned earlier, and it brings in our new stuff with the sum identity. Okay, one final thing to do. Let's, I claim that this is an identity. Well, we're going to prove it using a sum or difference identity. In this case, a sum identity. Okay, for the sum identity for sine looks like this. All right, so now x will be alpha and pi over 2 will be beta. All right, and then inserting it into our sum identity, we get this. Okay, sine of x is just sine of x. Cosine of pi over 2 is 0. Cosine of x is cosine of x. Sine of pi over 2 is 1. Okay. Sine of x times 0 is just 0. Cosine of x times 0 is 1. And what we get is, indeed, that it's equal to the cosine of x. All right. So the sine of an angle plus pi over 2 is equal to the cosine of x. And if you look back on example number 2, which was the sine of 105 equaled the cosine of 15. Pi over 2 is 90, right? Corresponds to 90. So the sine of an angle plus 90, or pi over 2, will be equal to the cosine of that same angle. And this is an identity that I'd like you to write down on your identity reference sheet. Okay, we're going to have all the identities on one single sheet, and add this to the identity reference sheet because this is a valid identity. Okay. All right, and then use this material to try the practice problems.